Today I want to talk to you about linear relationships. Our definition for linear relationships, we went ahead and put in our ISN. Our definition was a linear relationship is a relationship that is graphed as a straight line. Our characteristics that we have for a linear relationship is A, it is graphed as a straight line, and B, the table has a constant rate of change. Delta y divided by delta x is the same between any two ordered pairs in a table. Okay, so when we went ahead and we were looking at examples and non-examples, our examples here obviously know that they are straight lines. They don't necessarily have to go through the origin, but they are straight lines. Now, in a table, we know in this situation that one of the characteristics was in a table that has a constant rate of change, delta y divided by delta x is the same between any two ordered pairs in a table. Let's go ahead and test that theory out. Okay, in this situation I have my x values and I have my y values. Now my x values next to it, I need to write delta x and I need to write delta y next to these. Okay? Now if I'm going from -1 to 0, I know that of course I'm adding 1. And if I'm going from 0 to 1, I am adding 1. And if I'm going from 1 to 2, I am adding 1. And if I'm going from 2 to 3, I am adding 1. Now, when I go over here to delta y, my change in y, I'm going from -1 to +1. I know in this situation that I'm adding 2. If I'm going from 1 to 3, I am adding 2. If I'm going from 3 to 5, I know I'm adding 2. And of course 5 to 7, I'm adding 2 as well. Now, in order to test this theory out here, I need to see if my change in y divided by my change in x is the same between the two ordered pairs. So I'm going to go ahead and I'm going to do delta y divided by delta x. And I know in this situation, if I'm looking at my first two numbers here, I have 2 divided by 1 because my delta y value is 2 and my delta x value is 1. 2 divided by 1. Now, the cool thing about this table is if it's showing the same change right here and the same change right here, I can go ahead and just write 2 divided by 1 all the way down. You are not supposed to do that if the numbers change, but if they are the same, you can go ahead and do this. Now, 2 divided by 1 is obviously 2. Okay, so my rate of change for this table is 2. Now, I know that these values are going to be the same all the way down, so I know that it is an example of a linear relationship. This is an example of a linear relationship. Now, if I did this all the way down, like I'm telling you, it would be exactly the same. That is why I wrote an arrow. Okay? Now, these are all the same. Okay? So we're talking about a linear relationship. Now let's go to the non-examples. In your notebook we went ahead and wrote non-examples as well. Now these graphs right here are non-examples because they are not straight lines. They do not fall into the characteristic of graphed as a straight line. They are lines, but they are not graphed as straight lines. We need straight lines. Now we're going to go ahead and test the theory of the table has constant rate of change. We're going to do delta y and delta x. We have delta x and we have delta y, and of course I am talking about the change in x and the change in y. If I'm going from -1 to 0, I am adding 1. 0 to 1, I am adding 1. 1 to 2, I am adding 1. And from 2 to 3, I am adding 1. Now, over here, I'm going from -1 to +1. So, if we're heading in the positive direction, we're heading towards 0, we know we're adding. I'm going to have to add 2 to get from -1 to +1, so +2. If I'm going from 1 to 4, I'm going to have to add 3. From 4 to 7, I'm going to have to add 3. And from 7 to 11, I know I'm going to have to add 4. Now, in this situation, if I was going to do delta y divided by delta x, this would be, if I'm looking at my first set of numbers, it would be 2 divided by 1, which reduces to 2, and then the next one would be 3 divided by 1. 3 divided by 1 would give me 3, and then if 3 divided by 1 would give me 3, and then the last one would be 4 divided by 1, which gives me 4. Now, if you look at these numbers here, they are not the same. Okay? If the numbers are not the same, then this is not a linear relationship. Okay. Now, I want to go ahead and move on to pointing out linear equations or relationships, which was the homework that you were supposed to get on Thursday. Now, before I do that, let's go ahead and do an example. Let's go ahead and do an example. Right here, this says, is this linear? Okay, now it says, which of the following tables does not represent a linear relationship? So, obviously I know this is small, so you're just going to have to bear with me because this is going to be small handwriting. Okay, Actually, I guess I could blow it up over here. If I'm going from -4 to -3, I'm getting closer to 0, so I'm adding 1. Okay, I'm going from -3 to -2, I'm adding 1. -2 to -1, I'm adding 1. Over here, I'm going from -20 to -15. I am obviously getting closer to 0, so I am adding 5. And of course, I'm adding 5 all the way down. Okay, now in this situation, I know I need to find delta y divided by delta x. So delta y divided by delta x, it's of course going to be 5 divided by 1, 5 divided by 1, 5 divided by 1. So it's going to be the same all the way down. And when I end up reducing it here, they're all going to be 5. My rate of change is going to be 5. Okay? Now, in this situation, these are all the same. So what does not represent a linear? I obviously know that A is linear because it's going to be 5 all the way down. A sign that I know that that's true is that all these numbers are the same, all these numbers are the same. So it's going to have the same rate of change. So I'm going to go ahead and go to B. Okay, so B down here, I'm going from 1 to 2, I'm adding 1, 2 to 4, I'm adding 2, 4 to 5, I'm adding 1. I'm going from 20 to 10, I'm subtracting 10, 10 to 5, I'm subtracting 5, 5 to 4, I'm subtracting 1. Now if I did delta y divided by delta x, I'm going to write this down here, delta y divided by delta x, let's go ahead and talk about this first column. Which one is a y value and which one's the x value? I obviously know that this is going to be delta y and this is delta x. So I'm going to look at the first two numbers. So it's going to be -10 divided by 1. And -10 divided by 1 is -10. Let's look at the second row. The second row here says -5 divided by 2. So I'm going to write -5 divided by 2. Okay, and of course I know that -5 divided by 2 is obviously not going to be -10. Let's go ahead and do the math. It's going to be, how many times can 2 go into 5? I know that's 2. I know it's going to be a negative number because a negative divided by a positive, if the signs are different, it's going to be negative. And I also know that if 2 can go into 5 2 times, and then I have a half left over, so -2.5. Okay, now do you see that these numbers are not the same? These numbers are not the same. So I know that this is not it's not representing a linear relationship. So B is going to be my answer. Okay. Now I'm going to go ahead and stop there. Okay. We're going to go ahead and look at this pointing out linear relationships. You now have the skills to be able to do this. On number 1, I'm going to zoom out. On number 1, the question asks you, which of the following represents a linear relationship? I know the first thing, the characteristic about a linear relationship is that it is a straight line. So I'm going to go ahead and I'm going to pick the one that represents a straight line. Now, in 2, okay, in 2, I need to have a constant rate of change. So I need to do delta y divided by delta x on this table, this table, this table, and this table. And it's asking for a linear relationship. So I'm looking for, when I'm doing delta y divided by delta x, I'm looking for the constant. I'm looking for a constant. And here on B there was none, and on A there was the constant rate of 5. So what we're looking for in 2 is I'm looking for a linear relationship. So you need to go and set that up. And then this one says, which of the following is not true about linear relationships? Okay. You need to go ahead and read through these, okay? And if you need to look up terms, that's fine. And if you want to go back and you want to rewatch the video and maybe figure out what is true, what is not true about the values, then go ahead and do that. That's fine. Number 4 is another table, another graph, and then 5 of course is another table that you need to do delta y divided by delta x, okay? And then the last one here, you need to decide your answer choices. Okay, alright, so I've helped you out figuring out the tables, and I would like you to finish that up.